Hello, everybody. So this week we're gonna deal with lesson 14 and 15, page 165 to 178 in your textbook workbook. Okay, so we're gonna talk about the statement, true statement, and negation of the statement, and then we're gonna talk about compound and simple and compound statement. And then we're gonna talk about logic gate with logic gate and, or, and not. And then we're gonna talk about the truth table, and we're gonna work a little bit more on truth table next lesson. But I'm gonna introduce a little bit of it today, and also we're gonna draw the different logic gates here represent for circuits write out as a Boolean expression. I'm gonna put 15 questions up there from page 165 to 178 in your on Canvas, so you can complete for this week. Turn in, submit by 15. I'm gonna submit your assignment by November 15. All right, so let's walk through this problem right here, and I'm gonna begin to talk about statement. What is a statement? Statement is a sentence that either true or false, but you cannot have both at the same time. All right, you have either compound statement or simple statement. Okay, let's talk about statement first. What is a statement? Statement represent, it's like an equation. It is a sentence that represent either true or false. All right, but it's not both at the same time. So let's look at the example here. Paris is the capital of France. It is a statement, right? So I say yes, and you will have an exercise to do that on the other example. And Minnesota is a land of 10,000 lakes. That's for sure. Minnesota, all right. It's a beautiful state. That's why I live here for many, many years. All right, so Minnesota is the land of 10,000 lakes. It is a true statement. The next one is, would you like some coffee? Well, this is not a statement, but rather it's a question. All right. And next one is, I cannot find my library. Oh, I didn't spell the word library correct. Library. All right. And then that is it's not a statement. It's an exclamation. Okay. So anything about the command, the question, or exclamation, it is not a statement. All right. So statement, if let's say A, you have an variable assigned to this statement, you say A is represent the statement Paris, a capital of France. But is the negation of this statement, you write out A and you put a bar line on top of it. And some people put A and put out apostrophe. And some people do A and you put down negative A, this fine. You can use either three of them to indicate the negation of a statement. So if you do the assignment, it's very hard to type it in. If you want to type on the Word program, then you just do A apostrophe or negative A, representing the negation of the true statement. In Boolean algebra, we call that not. Is a not gate. All right, Minnesota is the land of 10,000 lakes. It's not the land of 10,000 lakes. Compound statement, you have the connected word like but, and, with, so on and so far, that preposition. So if you say you like summer, but I like winter, so that is a compound statement. Okay. The current mortgage rate is 2.3%, which is very good for this year. That is a simple statement. It's not a compound statement. All right. Move on to the to the logic gate, and, or, and not. Let's say if I assign A, B, C to three variables to three statements. Letter A for the I save the money, letter B I assign as I am rich, and letter C for I am poor. So if you want to write the Boolean algebra expression here, then you say I save the money and I am rich. I save the money is A, so I write out A. Now the word and is multiplication. All right, the word and represent for the multiplication. So I write out A times B. And I save the money or I am poor. The word or represent for addition. So if I write out I save the money, which is A, or I am poor, which is C, but in this case you add the word or mean addition. In algebra we call and is the intersection and or is the union. All right, I am poor, C, and I save the money, and I am rich, and I am not poor. I've saved the money is A, so and that means multiplication. I am rich, so multiply by B, and I'm not poor, multiply by C. Not poor, so you either put apostrophe or you put a bar line on top of C. So that representing the algebra expression for the statement assigned. Okay. So logic gate used for the circuit. All right. So if you're building the circuitry, you need to using different electrical signal. All right. So in computer and electrical signal, you can have on and off. So here I have one represent on, could be high, could be true, or could be closed switch. Off, it means zero, could be low, could be represent for false or open switch. Okay, so we have three basic gates that we learn here. Number one is and, number two is or, and number three is not. And in all, and later on you will have a truth table that go with the Boolean expression. And truth table is a table that contains all the combinations of the input values, the certain Boolean expression and the output that represent the true value of the Boolean expression. So we're gonna look at that AND gate first. So in Boolean algebra, the AND gate is like a little square with a half circle, all right, and straight line like this. To AND gate is the multiplication, all right. So when you have two inputs here, A and B, all right, and then you produce AND gate, that means A multiplied by B. So input A and input B gives output A times B with this AND gate. All right, and as you can see, the truth table, when you multiply 0 times 0 equals 0, 0 times 1 equals 0, and 1 times 0 equals 0, and 1 times 1 equals 1. True and true multiplied together equal true. All right, so next gate is OR gate. And OR gate look like a kite, look like a kite, look like that little curvy. And you got two inputs, A and B, and you give output A plus B. This is OR gate. All right, so OR gate is addition. All right, so you can see that A 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, 1 plus 1 equals 1. So that's a truth table for the OR gate. Okay, and the last one is NOT gate. NOT gate, it look like a triangle, right? Triangle. You have only one out input and A here, and you give another output with the little zero next to it. Some people write close to it, next to it, and put out A bar line on top. So it's NOT gate is a negation with, but if A equals 0, so A not equal 1. It's a opposite of the input. All right, so move on here. We have the example, so we're gonna deal with logic gate here. So I'm gonna zoom it in, and you can see that if you want to build a circuit that computes the function x times y plus not x times y. Okay, so times, so that means AND gate. So I put out AND gate over here. I'm using different color here. So I put down AND gate. That means multiplication. All right, so AND gate. And now I add together. So this is OR gate. So this is OR gate here. So what's the AND gate? AND gate for x and y, and OR gate for x and y plus x naught. So you have to do x input and output it x naught like that with the little triangle 0 next to it, and then y. So this is AND gate again. You multiply together. Negative x or not x multiplied by y, and then you add these two terms together. We call term. All right, so and the answer right there. Okay, let's get another example. So let have it. See, you have it. I'm gonna give different color here. So you have, this is AND gate. So AND gate for A and B, right? AND gate for A and B, that means multiplies A times B. So this one we call AB. All right. And now you got BC right here. So you got and another AND gate here. And you got BC. So I'm going to write out BC over here. All right. And then you have OR gate, and this is OR gate, and you got D plus E, D plus E. All right. So if you look at here, BC, so BC, and this is AND gate again. So you write out BC multiply, because AND gate, it means multiply D and E, D plus E, right? And then this is OR gate, so you add together, you add, we add with AB, So that is your answer. This is expression. You can bring it, put over here, the expression represent for this logic gate. Okay. All right, the last example, you can see this one. So you got 4 inputs, A, B, C, D, and you got not A. So this is not gate. So you put out A and little bar line on top, and also the same thing, B is outline on top, and this is the OR gate. So this is OR gate. So I put out C plus D. All that means you adding together, C plus D. And this is AND gate. So you multiply together. So you multiply together A not multiply B not. And then you multiply the whole thing with C plus D. C plus D. So this one equals Z. So that is expression represent for logic gate. All right, so next time when you come back for next week, we're gonna deal with lesson 16, which is two table, and then we can do some more example on that. So you got 15 questions on this assignment for this week, and next week we're gonna do practicing more two table. All right, have a good week. Bye bye. I will put the assignment on Canvas, and you will complete it by next week, Tuesday, which is November 15. All right, have a good week. Bye bye.